While most of the student teams are currently building their relay-controlled lift station systems, we have another student team working on a more advanced system. We are going to use a pair of submersible pumps in this large plastic tub. We're going to use them to pump water up to a higher level reservoir up here. And again, we are simulating the operation of a lift station, as you might find in a wastewater treatment system, where you have a large sump collecting wastewater from residences and businesses. As the wastewater reaches a high level mark, it trips a high level switch, and that activates one of these submersible pumps to pump the wastewater to a treatment plant. In this particular case, we're simulating it with clean water and with open plastic buckets instead of actual concrete sumps. And what we're going to be doing in this case is using these two lift pumps, these two submersible pumps here, to pump water up into the upper chamber. Now, when it's done pumping water into the upper reservoir, we're going to use the siphon effect to gravity feed the water back to the lower reservoir. The reason we have two submersible pumps here is to better model, better mimic a real lift station where you have multiple redundant pumps in the sump. The idea being that the control system will alternate which pump starts up based on either how much runtime the last pump has had or simply on which pump has been run the last time. The control system in this case is not going to be strictly relay. We're going to have some magnetic starters down here to control each one of the pumps, but the control decisions will be made by this Allen Bradley Slick 500 PLC. So it's a more advanced system than the simple relay control systems the other lab teams are building. Now once this thing is done, we'll have this as a system we can troubleshoot and have the lab teams, lab individuals I should say, come around one by one and troubleshoot this working system in the PLC section of the course. So we're going to use the Allen Bradley PLC to make the decision of which pump comes on. And we can do all kinds of fancy stuff with the PLC because it's got timers and counters and shift registers and all kinds of abilities to do advanced control. Things we can do include, as I mentioned before, alternating which one of the two submersible pumps start up based on either the runtime of the other pump or which pump was last to run. Another thing we can do is suppose we have a situation where one of the pumps starts up, it's pumping water out of this reservoir, but let's say for whatever reason it's taking too long to pump the water out of this reservoir. We can have the PLC run on a timer that says, okay, if it doesn't see the water pumped down to a certain level within a certain number of minutes, it will also start the other pump. Now this could be because the first pump is defective, or maybe the first pump has an obstruction in the tubing, or perhaps simulating the operation of a real lift station, we might be imagining a condition where we have so much wastewater coming into the reservoir that one pump on its own is not able to handle it. So the PLC can do functions like that based on time, saying, hey, if a pump is not pumping fast enough, not doing a fast enough job, it will also turn on the other pump for additional pumping capacity. And we can mimic that by placing restriction valves at the outlet of one of the pumps, or bypass valve, bypassing water back in. There's all kinds of ways we can mimic that sort of behavior. So that's what we're looking at here, is a simulated lift station controlled by a PLC. Or I should say that's what we will have, because right now it's still under construction. It's got a ways to go before we're running. But when we have this thing up and running, I plan to take a video of it and show the demonstration of the system in operation.